So today we are going to look at um, a kind of a visual technique in research that is called as model building for research. Actually, if you see, pictures speak 1,000 words. So instead of talking in length, a small picture can give a lot of meaning. And many of us, the learning style, we have different learning styles, visual based learners, auditory based learners, kinesthetic based learners. So there are different types of learners, and visual learners are more. So pictures help us to learn better. So we are going to use one such tool for our research, which makes us understand the entire research better. So if you look at the tools used for the visual learning and visual thinking, there are symbols. So symbols are a kind of a notation. So each symbol will have its own meaning, and it's a compact meaning that represents a particular information. So each symbol will have a particular meaning, and using those symbols, we can come out with a kind of a arrangement which will explain a lot of things. The second visual thinking tool is the map. So we have learned about the mind mapping. In one of our sessions, we were telling that research can be mapped into a kind of a conceptual map or a mind map. So that is another tool that helps us in visualizing. The third tool used for visual thinking is the model. Model is something representing the kind of the reality. So looking at models, learning again becomes very easier. So visual learning, in visual learning we have pictures, and in models there are different types of models, and models helps us to even learn better. So models are a representation of the real world. If you look at, there are different types of models, and what does model does is it gives a kind of representation of the real world. What are those different types of models? So we have physical models, mathematical and statistical model, economic model, logical model, process model, typology and topographical model. Then we have a theoretical model and conceptual model, which is more connected with our research methodology. I have some examples and illustrations to explain these models. A physical model. So physical model, a scaled down model of any real world objects. So for example, architectural models are models of the ship or aeroplane. So this is called as a physical model. What is a mathematical model? So representing the world phenomenon in a formula or an equation, that is called as a mathematical model. So we learned a lot of mathematical model, and statistical model is also part of a mathematical model. So look at this regression equation. So you'll be familiar with regression equation. Y is equal to a plus bx. So that is also kind of a mathematical model. So statistical models and mathematical models, they are a kind of model that we can use for understanding. Third one, economic model. So basically we learn about the supply and demand in economics. So a simple model of supply and demand will look like this. There are a lot of other models in economics. The learning through model is better than looking at the paragraph of information which talks about what is demand, what is supply. A simple model can give us more and more meaning. So this is economic model. Then we have what is called as a logical model. So we use logical models in computer science or in physics or in electronics. We use logical models. So in electronics, we'll have the truth table and logic model for the circuit building. So when you use electronics, you'll be building the truth table with the logical model, and you'll build the circuit. Similarly, in computer science, when writing program, you will have a logical model. So if this, then do this. If no, do this. Like that, we'll have certain programs. So that is called as a logical model. So models will tell us what to do in any case. So this is how it will look like. Then there is another model used in many areas, from manufacturing to even business process. It's called as a process model. So process model is like how from one stage to another stage we move through a process. So in manufacturing, a raw material is turned into a finished product through so many processes in between. Many projects, they will have kind of stages to go through, and that is also called as a process model. So process model is applied in many areas. So even a research process, when we call research process, we have a research process model, which I'm going to explain in another slide. So we have a research process model. See, please focus on this process model, because most of the researchers, they confuse with the theoretical model or a research model with the process model. That too, many of the scholars or researchers coming from industry, they have been trained to do projects, and they go through a lot of stages of process, and that they call it as a project. And in any research program, the research is also called as a project, research project. So that's why the master dissertation or thesis, or in undergraduate, any research work we do, we call it as a project work. So in most of the programs, we have project work. A lot of people confuse with the project work and the research. See, doing a project is not research, but research can be a project. Research can be a project, but project cannot be a research. So without knowing this, a lot of people think that if I do this process, my research is over. Not like that. So research is totally different. The philosophy of research, we started with that session. Research is something beyond all these process that we do. So we develop a questionnaire, we collect data, we analyze data, and we come out with findings. That gives a kind of a path or a procedure, which you may call it as a process or a project. But that is not entirely the research. The research is in the core, the meaning of what you are trying to do, why you are doing, what you are trying to find. That is where the entire research is there. So the process model and the research model, a lot of people get confused. So please understand the difference between a process model and a research model. The next one is the typological model. What is typological model? Typological model is something that categorizes or classifies things. So that is what is called as a type. Typology means classifying something or typifying something. What type of thing is it? So grouping them into some types or categories, that is called as a typological model. So what is a typological model? The best example, you can look at this personality model. In personality, there is a Myers-Briggs MBTI. It's a kind of a model which types of people, and it gives 4 letters to the personality type of a person. So we are trying to categorize or classify a person into one type of personality. So these kind of models are there. There are leadership models. You can look at this situational model, leadership, or even the very basic leadership model like task people model. We call it as a TP leadership model. So what is a TP leadership model? We categorize people into autocratic leader or a democratic leader or a laissez-faire or a country club type leader. So that is called as a typological model. Sometimes this typological model may be arranged into a kind of hierarchy. So then we can call that as a topological model. So there is a kind of hierarchy, or there is some order in it. So the best example for a kind of a topological model is our Maslow's need hierarchy model. So you know Maslow's need hierarchy. Earlier we used to have 5 needs. Nowadays it is increased. There are 6 needs and there is some extension to it also further. So that is arranged in a kind of an hierarchy. So in the bottom it is the physiological or biological needs. In the second layer it is safety and security needs. In the third it is the social needs. And the 4th layer is the self-esteem need. And the 5th layer is the self-actualization. So this is also kind of a typology, that is categorizing the needs, but there is a kind of an hierarchy or an order or an arrangement. Whereas if you look at these models, we don't say which is best. There's nothing, no order in this. The personality model or the leadership model, there is no order in it, just to categorize them. But in Maslow's hierarchy model, we have a hierarchy. So we can call this as a topological model where it shows some kind of a depth or length like that it shows. So finally coming to our theoretical model and the conceptual model. This is where our research models are there. But what happens is we interchangeably use framework and model interchangeably. What is a framework and what is a model? See, framework and model are almost the same, except for the contextual differences. But in research, whether it is a framework or a model, it is the same. It's almost the same. But we interchangeably use. So when you read research papers, research articles, you will see that this particular word framework is used in place of model, or model is used in place of framework. But coming to the theoretical model and the conceptual model, is there a difference between these two, theoretical model and a conceptual model? See, again, if you look at a lot of research papers, they interchangeably use it. They interchangeably use it. They call it as theoretical model or a conceptual model. But actually, if you understand the philosophy of research and the modeling guidelines, you will find a difference between the theoretical model and a conceptual model. So let me ask from you, can anyone tell what is the difference between the theoretical model and a conceptual model? Does anybody have an answer for this? What is a theoretical model and what is a conceptual model? Is there a difference between these two? Any answer?
So when we talk about
yes, sir. Yes, sir.
Sorry.
Saklesh, sir. Go ahead.
when I talk about conceptual framework, it can be very general from academic perspective. For whatever we have taken for pursuing as a field of study, that will have a background or a conceptual framework, And then when we talk about theoretical framework, there will be theories built relating to the subject, and it talks about an overview of various theories, introduction to the theories. So that's about theoretical frameworks.
So theoretical model, basically I explore all the theories that are related to my concept, and then I try and see how I can make connections between all of those. And I present that. But the conceptual model is basically how I intend to, it's like a guide, how I intend to take my variables and my work forward in my research. It involves my synthesis, how I want to proceed. So that's my understanding, sir.
Yeah. So any other answer? Anybody wants to?
Yes, sir. Yes, sir. So theoretical framework is, on what background, what theories, I am using for this particular research. And conceptual model is like, the input, what all the variables we are giving and what is the process and what is the outcome we are expecting. So that depicts, the conceptual model.
Okay, sir. Yeah, so
Sir, can a conceptual model be based on multiple theories?
We'll discuss about that. I just wanted what is your understanding so that I can answer that and get into the topic. Yeah.
Okay.
So coming to the discussion, so if you look at Saklesh sir was telling that theoretical model is a model of theories within a particular area, and the conceptual framework is beyond that, generalized one, and which covers beyond the theories, and that is called as a conceptual model. So maybe a generalized model is called as a conceptual model. The next participant and Prakash sir were telling that theoretical framework is kind of a model of the theory, and the conceptual model is that which I'm going to work on. Okay, so these two answers is almost what the thing that I wanted to explain. So getting into that, before looking at the difference between a theoretical model and a conceptual model, both these models, theoretical model and conceptual model, how does it help the research? How does it help the research? See, research as a process, we have understood. It goes through a lot of model. Theoretical model, you can say, is a kind of a core object. A theoretical model or a conceptual model or generally a model is the heart of any research or core of any research. Because if you have a conceptual model or a theoretical model, every stage of your research, you can relate it to the model, you can visualize your research, and it makes your research process easy and simple. And second thing is, if you have a theoretical model or a conceptual model, you can avoid a lot of mistakes that you will be doing. So I'll tell you one incident about one of the research scholar doing a PhD research, and the scholar had made a questionnaire, collected some 400, 500 sample data, and was starting to do the analysis. So while doing the analysis, it was a shock. The scholar found that did not measure the dependent variable. So only factors or only kind of independent variables were measured. The scholar completely missed out measuring some outcome variable or a kind of a dependent variable, and it was all over. 400 data already collected. All difficulties, 400 data was collected. But while doing analysis, it was found that one of the variable was not measured. What will happen? You cannot go back. You cannot again approach the same 400 people and map it. You need to match independent data to the dependent data. You need to match it. That is not possible. And again, collecting data from the same 400 people is again impossible. So this is one incident. Likewise, a lot of people, even yesterday we had a research committee meeting and one of the scholars was presenting. There was no connect between the topic, the research question, the research objective, the hypothesis, and the research tools or the statistical tools that the scholar is proposing. There was no connection. Why is this happening? Why is this happening? Why the disconnect between the different stages of the research happens is because the scholar is not visualizing the research. If the scholar can visualize what they are doing, what are their variables, how they are connected, then it will be very easy for the scholar to frame the topic, to tell the research question, to frame the research objectives and even the hypothesis. And looking at the model, the scholar will be able to tell what is the statistical analysis required, and thereby they can complete it. And the story of the research output. See, whenever we write an article or whenever we write a thesis, it is like a storytelling. So the story, from the beginning to end, there is a unison on the story. What I am trying to do and how I am doing it and what is the outcome. So there is a connect between that. So this connection, you will not miss it if you have this central theme or central core, what we can call it as a theoretical model or a conceptual model. So that is the strength of this illustration. Why do we develop a model for our research? See, some of the research, there is no need of a model, or model may not come out for a research. But trying to visualize your research is very, very important. So that is where the requirement of model in research was felt. So few years back, I wrote a research article on the importance of the conceptual model or theoretical model in research. How the researchers can use these models in every stage of their research. And what is the modeling convention? What is a modeling convention? So I made a research paper on that and published it. So I have shared that paper in the Google Classroom. You can very well read that paper. And actually that paper today has almost 7 citations. I'll share this. You can see this paper, Conceptual Model, a framework for institutionalizing the vigor in business research. So this paper today has 7 citations. It's coming. So citations are increasing. So this paper we wrote with an idea that the conceptual models will help the researcher in various stages of their research. So that's why I've brought this research process. This is a research process from C.R. Kothari's book. So every stage of your research, you'll be able to use the model. So at the problem definition stage, during the review of literature stage, while formulating the hypothesis, when designing the research, while collecting the data, while analyzing the data, and while interpreting and reporting, a model when you have, that is going to make your work easier. So that is the purpose of adding this particular topic into our workshop. So now coming to the theoretical model. So this I think we have already seen in the previous session. What is a theory? So theory is a statement which has the units which are connected, or the relationship, and there is a boundary and there is a proposition that comes out of a theory, And the purpose of the theory in research is, theory is the underlying factor of the entire research. So theories will help you to identify important factors to the problem. So you have a problem, and what are the factors related with that problem? What are those factors that can be brought out from the theories? Second thing is, it helps you to understand the relationship between those factors. All these things are coming out of a theory. What is a model? Model is a representation of a system that is constructed to study some aspects of the system or the system as a whole. So the difference between a theory and a model is that theory is a statement, is a word that explains what is a phenomenon. But whereas model is a kind of an illustration that represents the particular relationship. That is what is the model. So coming to the difference between theoretical model and a conceptual model, or a theoretical framework or a conceptual framework. So what is a theoretical framework is, if you convert the existing theory into a model, that is, you illustrate the particular theory in form of a picture, and that is called as a theoretical framework or a theoretical model. See, actual connotation may be different. As Saklesh sir was telling, what is a theoretical model and a conceptual model? Conceptual model is something that is general phenomenon, and theoretical model is a framework of the theory. But actually, if you come into the research process, what is a theoretical model and what is a conceptual model is all about the variables and their connection. Variables and their connection is what the theoretical model and the conceptual model. But the difference here is the truth, or what we call it as a validation. So a theoretical model is a model of a theory that is already validated. Theory means it is validated. Please understand. Theory means it is validated. So in research, we start from the theory, a validated theory, and end with the theory. Again, that is a validated theory. In between, that theory undergoes various stages. So that we explained in the last session, that you take a theory and you find a gap in the theory. Then you try to address that gap, make some modification to that theory in the form of some assumptions or hypothesis, that you try to test through data. The data is the evidence that you bring in, and when the evidence is available, then the assumptions gets validated, and once the assumptions are validated, that becomes a theory again. The theory, from the beginning to the end, there may be minor changes. So that is now an incremental theory. So the theory has been incremented to one level. So that is why research, every research is a kind of an incremental research. So we take a theory, we increment a theory. Some small modification we make and we push it. So that is the increment to the theory. So whatever existing theory that is validated and you model it or you draw it, then that becomes a theoretical model or a theoretical framework. At the same time, when you make changes to that, you make changes to the theoretical model, you make some rearrangement, and that is yet to be validated, that becomes a conceptual model or a conceptual framework. So that is what Prakash sir and the other participant were telling. So which I want to test it. So conceptual model is something that I want to test it, but a theoretical model is something that is already tested. So when doing a review of literature, if I come across a theory and that theory, I model it, that is a theoretical model. A model that is representing a particular theory. But at the same time, if I make modification to that, add a variable or change a connection, and I use that for my research, and that becomes a conceptual model or a conceptual framework. So during research, what happens? The conceptual model gets converted into a theoretical model. A conceptual model, when the evidences are available and the relationships are proved, when the relationships are found to be true, then it becomes a theoretical model. So you give a theoretical model. So that is what the difference between the theoretical model and a conceptual model is. So again, finding out the relationship between the real world, the theory, and the model. This is how it is connected. So the model is an approximation of the real world. Model is an approximation of a real world, whereas theory is a denotion of the real world. So it denotes the real world. So this is what we do as a knowledge. In different forms we present. That's all. We present it as a theory in a statement, or the same thing we present it as a model, as a picture. So that is what is the connection between the real world, the theory, and the model. And a model that is for a theory, that is a theoretical model, but when an idea is added to it, it becomes a conceptual model. So we will do an exercise. Okay, we will do an exercise. I asked you to bring some research papers. So you need to read one research paper, and whatever the theory that they are coming out with, what theory they are coming out with, that you try to model it. So we will call it as a theoretical model. So that is the first exercise we are going to do. And the second exercise will be, you will have to make a modification, or you will have to add something into that model, and you will have to present a conceptual model. Okay, so these two exercises we are going to do. But before getting into the exercise, I need to tell you the convention of the modeling. Because whenever we say a theory or a model, whatever we do in research, it is universal. Please understand, whatever we do in research, it is a kind of a universal knowledge. It is going to be used across the world, or whatever research you are going to do and the outcome that is going to come, that is being read by people across the world. So when you are presenting your research to the outside world, when you follow certain standards, then it becomes easier for us to convey the message. That is where we have standards in our research. You take the citation and referencing. We are forced to follow a particular style. We call it as an APA style, or we call it as a IEEE style, or we call it as an Harvard style. why that is being followed. So we can specify the source of information in a very short form. In one line or 1.5 lines, you can tell where this particular information has been taken from. So you will have the author name, year, title of the article, journal name, volume, issue, page number. So this is a kind of a short form, an universal standard form to inform anybody from where this particular information was taken from. The same way, we can develop a standard for the model also. See, actually, there is no standard that exists. Okay. Universally, nobody has made it as a mandatory, or no agency or no body has come out with the standard for this modeling. So my attempt, my paper was the first paper to tell that let us follow some standard. But actually, the standards were available earlier, not as a kind of a mandate. So each researcher were trying to use their own conventions into the model. So what will happen is the communication. What we are trying to say through this particular model, that doesn't come out. Where you need to further explain, only then the people will understand what you are trying to convey. So that was the situation. And that is the situation even today. So that is why, at least for a small crowd, we can make some changes. So we go through this particular workshop on conceptual model building, where I try to tell some standard how we can use certain notations which will be understood by people across the world in a similar way. Actually, this the grammar or the notations of the conceptual model or a theoretical model is being used in different graphical statistical tools like the structural equation modeling. So many of you would know structural equation modeling. That is a statistical technique. That's an advanced statistical technique where we try to model and then test the model as it is by a graphical user interface where we try to draw the model and then test it. So when we are drawing the model in the particular software, you need to use a particular symbol to tell the software. So why don't we use the same symbols or the images for creating our model, so that people across the world can understand what we are trying to say. So that is how we developed the standards for the conceptual model building. So there are a lot of other standards like UML, Universal Modeling Language. Universal Modeling Language, UML. Based on that, a lot of streams like engineering, computer science, they have already adopted the standards for the modeling, except for research. So we try to bring in both UML as well as the research softwares that is available. We try to merge them and come out with the modeling grammar. So many of you would have learned flowchart, computer programming flowchart. When I was learning, I was learning basic language. So you all know computer languages. Today it is more advanced, but when I started, it was basic, COBOL, Fortran. So those were the computer languages. How did we learn? Before writing a program, we need to draw a flow chart. There is a notation for the flow chart. Square means it will indicate something. A circle means will indicate something. A rhombus means will indicate something. And the arrows will indicate the direction. So there was a universal understanding of the model. The same thing, same way, for our research models, or what we call it as a theoretical model and a conceptual model, let us use these symbols. So carefully listen to this. And whenever you are creating a model, whenever you are trying to represent your research in a modeling language, try to use this particular symbol so that it is easy for people across the world to understand. And this is the symbol that you will be using in most of the structural equation modeling softwares. So if you are presenting your model with these symbols, you will not require to even explain the model. It will become self-explanatory. If you project a model and say, this is my research, it's very clear. People can understand what is the independent variable, what is the dependent variable, what is the mediating variable, what is the moderating variable, what are the relationships you are proposing, what is the measured variable, what is an abstract variable, what is a factor, what is a construct, what is the dimension, what is an item. Everything will be clearly understood if you use this modeling grammar. Your research, just one PPT where you have the model, you can just project it and you can start speaking on your model. Everything is embedded there. You can talk about what is the review of literature you are doing, what is the hypothesis, what is the research question, what is the objective, what is the analysis you are going to do. Everything you can easily explain using your model. So what is this symbols? We'll look into these symbols. So square or a rectangular box, what does it mean? Square or a rectangular box, what does it mean is, we call it as an observed variable or a measured variable. Sometimes we call it as a manifest variable, an indicator variable, or even as a reference variable. See, think of a questionnaire. Think of a questionnaire, a survey questionnaire or a survey instrument that you are using. Each statement or each question that you are asking will be represented with a square box in a model. Each question that you are asking will be represented in a box. And this circle or an oval, what is it called as? It is called as an unobserved variable or a latent variable, or a factor or a construct, or an error or a disturbance. Error and disturbance are explained at the end, but since error and disturbance also are not measured, they are being shown as a circle. What is an unobserved or a latent variable? See, in your survey instrument, you may ask 3 or 4 questions, or 5 or 6 questions. To measure one concept, an abstract concept, you will use 4 or 5 items. Each question is called as an item, which is represented as a square box. But whereas all these 5 items or 6 items is going to indicate a particular concept. It's going to indicate a particular concept. So that is why whatever individually you are measuring, they are called as the indicator. And the concept that is being measured with the independent items, they are called as a latent variable. Latent variable means it is not directly measured, it is indirectly measured from the items. Indirectly measured from the items. So that is called as a latent variable. So anything that is calculated, anything that is created from the other measures, that is represented in a circle. That is represented in a circle or an oval. So there is a chat question. How are control variables represented? See, we don't have the question of whether it is an independent variable, dependent variable, or control variable, or a mediating variable, or a moderating variable. Here I am talking about whether it is measured or whether it is not measured. Your control variable can be a measured variable, or your control variable can be a created variable or a calculated variable. If your variable is a calculated variable, then you need to draw using a circle. If you directly measure it, then you are representing it as a square. So I am only talking about the representation, not the arrangement. See, whether it is an independent variable or a dependent variable, whether it is a control variable or a mediator variable or a moderator variable, is understood only based on the position of the variable in the model. Position of the variable in the model, which I explained in the previous class itself. It's a temporal. It's a time, and the arrangement of a particular variable is what indicates whether it is an independent variable or a dependent variable. If the variable is on this side, it is an independent variable. If the variable on this side, it is a dependent variable. So that's the arrangement. But if it is a square box, it means that I will understand that this is directly measured. If it is a circle, then I will understand that it is not measured, it is constructed, or it is calculated, or it is a combination of measured items. That is what is your circle or a square is. So then coming to the arrow, a single-headed arrow indicates the direction of the relationship. Single-headed arrow indicates the direction of the relationship or the kind of impact. It's a kind of impact. Or sometimes the single-headed arrow is called as loading. We'll come to that. What is a loading? How do we understand a loading, or how do we understand the impact? Loading and impact are different. Loading and impact are different. Loading means each item is loading into the construct or the latent variable. But impact is influence. One variable is influencing the other variable. That is called as the impact. So for both we'll be using the single-headed arrow. We need to understand that. I'll show you some examples. You will be able to understand. So single-headed arrow is for both loading as well as indicating the influence or the impact or the direction of the relationship. Double-headed arrows. What is double-headed arrows going to tell us? Double-headed arrows are going to tell that the relationship between the two variables that are connected, it is a mutual relationship. It's not one-side relationship. It is a mutual relationship. So what we call it as a correlation or a covariance. last class also I explained what is a correlation. You can change the variable this side and that side. Like a chi-square test, you can change the variable between row and column. Similarly, in correlation also, you can find correlation between X and Y, or you can find correlation between Y and X. Both will give the same results. So there is no direction. There is no particular direction when you are relating a variable as a correlated variable. Then we indicate that with the double-headed arrow. So double-headed arrow means it's a mutual connection or a relation, correlation or a covariance. Then coming to this symbol E, which I have drawn here on a square box on a circle. What does that mean? See here, X and Y are measure. X and Y are measure. We are measuring something. We are measuring something. And whenever we are measuring something, there is something called as a measurement error. Measurement error. So that is what when you calculate the standard of any measure, when you are calculating the standard of any measure, an error comes out. That's called as a measurement error. While you are measuring, there can be some error that is coming out. That is called as a measurement error. So any measure that you are measuring plus the error is the actual measure. For example, I want to measure this pen. I want to measure this pen. I will take a scale and measure this. I'll take a scale and measure this. So whatever is shown on the scale, that is what I am measuring. But still there is an error. Maybe the scale, the scale is the ruling is done. There is some error. Or my eyesight is poor. There is a parallax error. I am looking from this way, but actually this way. So there is a parallax error. So whatever I am seeing on the scale is not the actual measure, but that is a measure plus error. That is what is the actual measure. So in social science also, in whatever we measure, let it be some attitude or personality or leadership which we measure through any scale or in a questionnaire. We call it as a questionnaire or a survey instrument. Every measure will have something called as a measurement error. So that statistics, when we are doing statistics, it comes out of statistics. Okay. So I'm not going deep into statistics. So when you get the data and when you put it into SPSS, when you analyze the data, the system SPSS itself calculates that measurement error and it stores in the system. So based on the measurement error only, it does some further calculation. That is called as the measurement error. Measurement error is always on the measured variable or the observed variable. So whatever we draw on a measured variable is the measurement error. Please understand that. At the same time, whenever I am drawing a error on a latent variable, this is called as a disturbance or a regression error. It's called as a disturbance or a regression error. So I will just illustrate this. What is a disturbance or an see any regression equation when we write it like y is equal to a plus b x. We don't end here. We have another notation, the e. If you look at a regression equation, there are three things. This is constant. This is constant. This is the regression coefficient. And this is the error, regression error. Okay. So it is something like this. So when I am plotting the regression, so we'll have the points lying. So some points will lie exactly on the line, some points will lie outside the line. So the distance between this line and this point is what the error is. Okay, so we cannot exactly predict. There is always a kind of an error. So that is called as the disturbance or the regression error that we are noting it here. So these things actually, these two things we do it in the software. It's not required for presenting a model, because this is within the calculation that it comes out. Measurement error and disturbance error comes out in the calculation. We don't present it in any research model. Okay, so but for understanding, please know that a measurement has an error, and also the latent calculation also has some error. So these two things we will be using in the software. So, but for our understanding, we will use these four symbols for representing your model. Let it be theoretical model or a conceptual model. So, but use these symbols for making the model. So what I will do, I will give you time. Okay, so I asked you to bring some research articles. So take one good article. Take one good article and try to go through that article, and whatever that paper has found. So don't look at the well-established theories that they have referred. Okay, so that everybody will be able to find out. That is easier thing. Try to model what this particular researcher has found. That is also a theoretical model. That is also a theoretical model, because that researcher has found the evidence and he has validated that particular model, or he is presenting it as a theory. So find that, and maybe how much time you will require? 10 minutes, 15 minutes?
So 15, 20 minutes, sir.
15 minutes we'll have. Whoever is coming, we will share it and we'll present it. Okay, because we have one more exercise of the conceptual model. Okay, so within 2 hours we'll have to finish that. So we have spent 1 hour on this presentation. So if you can take 20 minutes, then I have another 10-15 minutes of presentation, and then another 20 minutes, 15 minutes you can take, so that you can develop the conceptual model, and then further discussion, then we can close our today's session. Okay, so take some 15 minutes. Okay, and I am available here. You can ask me any doubts. So I am there to clarify, but try to read your paper and try to convert that into a model. So I will project this symbols, so you can refer to that and you can start working on your model.
Hey, Rupa. Hello?
Yes, ma'am.
Rupa.
Sir, I have a question on the
Yes.
slide that you have shared. Here in symbolic use is measured by items 18, 19, and 20. Am I right, sir?
Symbolic use is measured by 18, 19, and 20. And there is something coming from Y21. So that is called as a cross loading. If you know what is factor analysis, in factor analysis we have a discriminant validity. So this actually is a representation of a cross loading. So this Y21 is not only indicating instrumental use, it is also indicating the symbolic use.
So in our model, should that cross loading also be represented?
No. Here, I just brought it to show you all. But actually, cross loading should not be there in your model. So that is what in structural equation modeling, the first stage is CFA is to find out if there is any cross loading so that we can remove that.
Sir, so if I'm right, the whole research, whatever of this paper had a total of 23 items that measured everything.
Yes.
Okay, thank you, sir.
Further to that, there may be demographic variables, but these are the first variables or the measures for the concept.
Okay, thank you, sir.
23 questions they would have had.
Okay, so we can either use X or Y then as measurement. That is up to us. Okay.
Yeah. That you can see in SPSS how do you code? You can even call it Q1, Q2, Q3 like that. Also you can name it.
Okay.
Sir, here where is this measurement error, sir? I was just curious to know.
Here measurement error it's not shown here.
Okay.
Actually, it will be like this. You see here on mental health, you are seeing this. No, this is called as the measurement error.
Got it, sir. Okay.
Similarly, the regression error will be like this. This one, D1, D2, D3. That's a disturbance or it's a loading error, factor loading error. Similarly, regression error will be there. Regression error. Yeah, this is regression error. C4 here is a kind of a regression. It's not measurement error. This is a kind of a regression error sometimes on a dependent variable.
Thank you, sir. Got it.
If anybody is working on a Word file or if you are using a paper, you can just take a snap of it so that you can present. Has anybody finished? If you are ready, I can give share permission. You can share the. Yeah, 20 minutes over. Is anybody ready? If you are not ready, what I can do is I can ask you to submit in the Google Classroom so that I can proceed with the further topic on the conceptual model. Okay. So is it all right, or anybody presenting? No response.
Sir, may I? Sir, am I audible?
Very feeble. You need to be loud, little loud.
Sir, I found a paper
Huh.
that has a structural equation where the author has done a structural equation modeling.
Okay.
So he himself has pictorially represented what is the model that he used as a base and what is it that he has converted. So I have taken screenshots from that. I just had to read the models. The pictorial representation was already done.
No, there what you need to understand is the model that goes into the analysis is the conceptual model stage. But after validation, what is validation there is maybe some paths are not significant or may not have an impact. Those paths will be removed and presented again, and that becomes the theoretical model. Is it clear?
Yes, sir.
So do you have the final model where all the results where the insignificant paths are removed and it is shown there?
Sir, it is not insignificant variables, but the original variable, it said that there is random interaction among the variables, but he has said that there is a sequential interaction. So that is the difference that he has done. He has even measured and
he has tested whether there is a sequential interaction. That is okay.
yes.
But what is the result he is finding? Whether he is finding that all his proposed hypotheses are accepted or rejected, what is that is happening?
1 minute, sir.
That is what will tell what is the final model. In a research in the beginning, the researcher may propose various relationships. But after collecting the data, after testing, the researcher will come to a conclusion that not all the relationships have been proved. Some of the relationships did not, the significance is not there. So he will say that the hypothesis is not proved. So those relationships you need to remove, and whatever he has proved, that will become the theoretical model of that particular paper. Anybody is ready? Okay, so I will maybe I'll have to complete the presentation and then wait for people to present. Okay, so we are here creating a theoretical model. So I told you how to develop a theoretical model. So now coming to the conceptual model. So from a theoretical model, from the previous theories, whatever model you create, you connect it with your current problem, and you find that the theory is not completely explaining your problem. That is what we call it as a research gap. We call it as a research gap. Then what we do is we propose to address that research gap, fill that research gap. Maybe we will include another variable there, or we may change the relationship there and try to propose saying that this could be like that. That is what is called as the hypothesis. So that is what a conceptual model now becomes an intermediate theory. A conceptual model now becomes an intermediate theory. That is a proven theory with some minor modifications, which is not yet tested, will become the intermediate theory or the conceptual model. So this conceptual model, whatever you develop, will help you to define the problem, mention the purpose of the research, do review of literature, specify the methodology, collect the data, and do the analysis. So that is why conceptual model acts like a map that gives coherence to the empirical inquiry. So having a conceptual model will help you throughout your research. If conceptual model is there, I know what I'm going to measure. I know what analysis has to be done to prove the hypothesis. I know what is the research question that is emerging. What is the objectives I can set? So from the model, you can go backward. From the model, you can go forward. So any researcher, while working on their research, from doing the review of literature, even in review of literature, you are trying to develop maps. At the same time, parallelly, you can develop the existing model, theoretical models. Look at your map, look at your models, connect it with the problem, and develop the conceptual model first before writing your objective or writing your research question or writing your topic. Before you start writing or putting it into any statement, develop the model, a visual model of your research. Then it becomes easier. So, as I told you, it's an intermediate theory. And what do we try to do there is something we try to bring in. We try to include maybe a new variable as a factor, as an independent variable. Or you may try to include a mediating variable, a new mediating variable. Or you may try to include a new moderating variable. Or you may try to change the path. If the path is from this variable to this variable, you may change the path. These are some kind of testing or novelty you try to do. So that novelty, you should not do it randomly. A lot of people, a lot of researchers I am seeing, they plug some XYZ variable into the model. They will take a theoretical model, or there are people, what they do is they will take 3 or 4 different theories, theoretical model, 3 or 4 theoretical models, and they will take one variable from each of those models and try to create their model. That is not novelty. That is not something conceptually you want to create. As I told you, research is incremental. Every time you can make one small change, not this cocktail of change. Or it is not like cooking. You put this ingredient, you put this ingredient, you put this ingredient, you put this ingredient, mix it, you get a new theory. Not like that. So you take one theory, or you take a theory that is more connected to your problem. Then between the theory and the problem, there may be a gap. Don't try to find a gap from all the theories. You first evaluate all the theories, compare all the theories. Among all these theories, which theory is very close to my problem? Which theory is very close to my problem? That theory you take, and between that theory and the problem, what is the gap? That gap you try to address. So don't bring variables from different theory and mix it up all in one go. No. You make one change. You introduce one variable, that is enough. That is one research. You change one path, that is enough. That is one research. You include one mediator, that is enough. That is one research. You include one moderator, that is enough. That is one research. Likewise, you try to make a small increment to the available research. That change has to be supported by the literature. So even if you bring one new variable into the particular theory, there should be literature telling that this could have been a factor there which has not been tested. So some kind of literature support is required. So that may come out of various intuition, experience, or what we call it as a disciplined thought process, not a wild or what you call as a brainstorming kind of a thought process. We call it as a disciplined thought process. So last week in the theoretical model development or theory building, I told you that disciplined imagination is one way of developing new theories. What is the disciplined imagination? The novelty or the newness that you are trying to bring in, that is coming out of a proper structured thought process or with the support of various evidences. That is what is called as a disciplined imagination. It's not wild imagination. It is not dreaming. It is not dreaming. Even disciplined dreaming. How do you dream disciplined way, structured way? So there is a kind of reason why a new variable is added. So a thought process, a conceptual model development is a thought process taken by the scholar to explain, understand, or change something with a disciplined imagination. So please understand, this is where all the scholars are making mistake. They are plugging and playing with variables without any theoretical background. See, when you take one variable from one place, another variable from another place, third variable from another place, you put together and you bring out a conceptual model and you present it. What is your base theory of it? You cannot name all the three theories because it is not complete. It is only one variable from each theory. It is not a complete theory. So the base of a theory that you completely miss, you cannot say on what theory you are working. On what theory you are working or what theory you are trying to improve. You may not be able to say that. If you are just trying to plug and play, you will not be able to tell what is the foundation or fundamental theory on which you are building your new research. So please take care of this because most of the researchers are trying to do this without any foundation. Because as I started in the first class, what is research? Find some 4 or 5 variables and find some survey instrument for that. You create a questionnaire, you collect data, you analyze the data, you have the hypothesis, you test the hypothesis and you write the thesis. That's all done. That is what is research. If that is the case, Everybody can do PhD, everybody can do research. Why people are breaking their heads coming to this kind of workshops? If it is just making a survey instrument, collecting data and doing analysis, if that is the PhD or if that is the research, then everybody should be able to do. That is what you need to understand. What is the difference you are creating there? So the fundamental theory, you should be able to talk theories. You should be able to talk about comparison of theories. You should be able to talk about gap in the theory. And then you need to be able to address that gap and then come out with a new theory. That is the work of the researcher. Not making cocktails, not making sambar. That is not PhD research. Please understand. So disciplined imagination is very, very important. And disciplined imagination and the model building and the practice, they are all connected together. What I see, I put it into the model. So see or read, draw that, and then imagine, synthesize, and again try to visualize that. That is the cycle of this model building. So why we are doing model building? So the next exercise was create a conceptual model. So I thought of taking one theoretical model that you are bringing in and asking you to address a particular gap in that theory and then make it into a conceptual model. I hope you have not done that exercise. Maybe you require some more time. I'll give you some time. So what you can do is you can submit it where you present a theoretical model and below that you present the conceptual model so that I can find out what is the change that is coming in there. So from the theoretical model, how you have arrived at the conceptual model, let me understand that. So I have this presentation loaded in the Google Classroom. Okay. So you can look at this presentation. There are sample models I have presented. But actually, if you see, they are not completely as per the grammar which I told you. Okay, so don't take it at the face value of it. You apply the grammar and you try to understand and change it. But I try to collect some models to explain not only modeling grammar, but also how we identify variables or how we look at the model and understand what is the theory or what is the kind of relationship between the concepts that is coming out. So rather we can call that as how to identify what is independent variable, what is dependent variable, what is mediating variable, what is moderating variable, like that. So I had brought some sample models. So let me quickly go through that. Okay, so we have just 15 minutes. We will quickly go through that so that we can spend some time on your question and answer. So this is, you can see this is education, income, occupational status. These are measured. And these variables create what is called as SES. But there is, don't look at this arrow. I am going to tell you what is this arrow when it is like this. There are two types of constructs. I'll come to that. Just look at this. This is called as exogenous variable because exogenous means variables that are independent. So instead of calling it as an independent variable, we call them as an exogenous variable. So here we can see independent variable, dependent variable. So when the direction is like this, right, left side is independent variable, right side is your dependent variable. This arrow will indicate what is independent variable and what is a dependent variable. Coming to this endogenous variable. So there is only one exogenous variable. All these variables are called as endogenous variable. Endo means inside. So all these variables are inside the model or is dependent on this first variable. So this first variable is the exogenous variable. All the other variables are endogenous variables. That is how we tell in a sequential model, because in a sequential model, what happens is, in the first level, this is independent, these are dependent. In second level, this is independent and this is dependent. In the third level here, this is independent and this is dependent. So if this model is given to you, how do you identify what is independent variable and what is dependent variable? You cannot do, because the same variable is independent as well as dependent. Therefore, we have a different name for that. We call it as endogenous variable and exogenous variable. So what is this? This is exogenous variable. Product presentation feature is exogenous variable, and all the other variables are called as endogenous variable. Then here you can see latent variables. So these are measured variables. These are latent variables. It means that this particular variable, cooperative goals, is not measured. It is measured by 3 items. And those 3 items will make this particular variable. Okay. So likewise, you can understand the connection or the influences from the latent variable to latent variable. Okay. So this is latent variable. So again, this is the latent variable. So mindfulness is measured by so many items. 14 items makes the mindfulness variable.
Sir,
Yes, sir.
Correct me if I am wrong, sir.
Yes, sir.
Like, for example, when I want to measure any sustainability of any of the particular innovation or whatever, I cannot measure directly the sustainability.
Yes, sir.
And one way I can measure is as a criteria, like quality of service is also one of the criteria which can define sustainability.
Okay, sir.
In this case, can I call it as, like quality I am measuring actually? In a way, I am actually measuring the sustainability. This is
through quality, you are measuring sustainability.
Yes, yes, yes.
So that, but actually quality also cannot be directly measured. You will have to measure it with some measurable parameters.
Measurable variables.
What is quality? That you will have to define it in a physical parameter. So that physical parameter will indicate quality, and that quality will indicate the mindfulness.
Okay, okay.
Sustainability. So that kind of thing is called as second order or third order latent variable. Sustainability is a second order latent variable, because quality is also a latent variable.
Right, right.
And some parameter is your first level.
Okay, okay, sir.
So that is how it will look like. I'll just draw it, sir. So I will say, that some dimension, length. So length is the quality parameter. Length is the quality parameter. So this length is going to indicate quality. It is indicating quality. Length is indicating quality, and this quality is indicating sustainability. So this is called as a second order latent variable. Second order latent variable. So that is what I'm going to show, that kind of model also.
Okay, sir. Okay,
so what is measured and what is not measured? That is what we need to understand in the modeling. So coming to this formative and reflective variable, that is the confusion of the arrows. So you may ask, this cooperative goals, you are saying that it is being measured by Y1, Y2 and Y3. But why the arrow is in this direction? That is called as, this arrow is called as reflectiveness. This arrow, the direction, if you see, it is from the latent variable to the measure. So we call this entirely as what is called as a reflective variable. Reflective variable. So most of our latent constructs are all reflective constructs only. Most of our variables are reflective constructs. But there is something called as a formative construct. There is something called as a formative construct where the arrow will be like this. But this arrow is not influence. We need to understand that this arrow is not influence. This arrow is also a kind of loading, but it is called as a formative loading. It is called as a formative loading. So I can give an example. So a formative construct is like our we can say that evaluation of a subject. Evaluation of a subject, that is a latent construct. So then we will have CAA 1. CAA 1. That is one component, this one. Then we will have CAA 2. Then we will have CAA 3. CAA is the continuous internal assessment. So continuous evaluation we are doing. At the end, we will have what is called as end semester examination. End semester examination. All these put together is called as the performance in a subject. Let us say that it is the performance in a subject. In maths, we will say performance in maths. So how is performance in maths is measured is, what is my CAA mark? What is my CAA 2 mark? What is my CAA 3 mark? What is my end semester mark? All put together is what will indicate the performance in maths. Here, what is the difference between this reflective and the formative construct is, even if one item is missing, this variable is not complete. But in reflective variable, in factor analysis, what we do is sometimes when there is a problem, we try to drop the item. So we may have 4 or 5 items indicating the diet. But after collecting data, we will run a factor analysis and we will find that this particular variable is not contributing to the measurement of diet, or this variable is not contributing to the measure of diet. So then we will remove this variable. Even if you are aware of statistics, in Cronbach alpha, we'll be calculating the reliability. We will try to find out if reliability is low, maybe one of the particular item is creating the problem, and we try to find out and remove that item. So in research, in a reflective latent construct, we are dropping the variables that is allowed, because even if I drop this particular variable, other variables will measure the particular variable. But in this case, if one variable is missing, then this variable is not complete in measurement. So that is called as the reflective and formative constructs. This is a little complex. It will take some time for you to understand. So you can have this PPT, you can go through it, you can understand it. When you come to measures, then you will understand better. So, but try to understand the arrows here are drawn like this to say that this particular variable is indicating this variable. This particular variable is indicating this variable, whereas this arrow mark says participative climate is influencing the level of participation. Our level of participation is influencing the participation efficacy, but this arrow mark is participation efficacy is not influencing Wi-Fi. Instead, participation efficacy is being measured by Y50. So this you need to understand. This is reflective variable and formative variables, and this arrow marks are influence. These arrow marks are influence. So you will better learn this in structural equation modeling, but you need to just have a fundamental idea. Okay. So formative constructs.
Sir?
Yes, sir.
Yeah, sir, can we?
Yes, sir. I'm not hearing you.
Yeah, yeah. Can I, sir? Prakash this side, sir.
Yes, sir. Yes, sir.
Yeah. So in reflective variable, for example, like you mentioned, like 4 or 5 variables are there. Like 1 or 2 variables we can afford to ignore.
Yeah.
Sir, is it provided if it is not having a significant impact on that measure variable which we are going to measure, right, sir? Or any case we can ignore, sir?
No, no, sir. If any significant, we don't call impact significant loading. Loading.
Okay.
We call it as loading. That is, this particular item is not contributing to the measure. It's very, very insignificant. Maybe we in factor analysis, what we do is any factor loading less than 0.5, we try to ignore.
Ignore. Okay. Okay,
So
sir.
we say that this is not giving much of contribution to the measure. So then we drop those items. That is what that is called the reflective. If it is only a reflective variable, you will be able to drop it. If it is not, because in a reflective variable, even if I drop a variable, other variables are indicating the particular concept. That's why we call it as a multi-item construct. So multiple items we are creating so that different even if one measure is not indicating, other measures will indicate. So the concept of multi-item itself is to have more reliability and validity of the measure. So that's why we say don't measure one concept with just one question. Don't measure concept with one question. Try to measure it with multiple questions or multiple items so that the concept is measured better. So these are all, I think it has to be taught in the next topic, that is instrument development and instrument validation. So I'm trying to just show the model. So modeling convention, that's all. So maybe we can discuss in length about these formative and reflective with examples in the instrument development class. Okay. So again, you can look
Sir?
at, yes, madam.
Sir, can a model have both reflective as well as formative construct?
Yes, yes, yes. A model can have both reflective and formative construct, and you can run it. You need to show that. Yeah. So these are different models, sample examples. So here you can see this is a formative construct. Website performance. Arrows are coming from here to here. So this is kind of a formative construct. So reflective constructs. This is a formative construct. This is a reflective construct. So again, some more example for formative and reflective construct is also given. So please go through that. So there is one more type of model. We call it as a non-recursive model. What is non-recursive model? When there is this is not a mutual relationship. This is a mutual impact. Please look at this arrows between trust and perceived risk. It is not a double-headed arrow I have shown. Trust and perceived risk, I am not showing a mutual relationship, but this is a mutual impact. Trust is impacting perceived risk. Perceived risk is impacting the trust. So this kind of model is called as non-recursive models. It's called as non-recursive model, and where there is no return arrow, that is called as a recursive model. So usually most of our models are recursive models. Rarely you will have a non-recursive model. Okay, but you need to understand, if you have a mutual interaction like this, it is supported by theory saying that trust influences perceived risk. And there are theories which says perceived risk influences trust. Bringing them both, we are drawing two lines that is leading to what is called as a non-recursive model. Okay, so this is how we indicate moderator in a model. Moderator is the impact on the relationship, not on the variable. Moderator is an impact on the relationship. That is why we draw this arrow to the path. We draw the arrow to the path. If the same thing, if I am going to draw a line to the variable, say like this, if I am drawing, it means that this variable is impacting this variable. I am drawing it to the path effect. So it means that moderator is always impacting the relationship between two variables. So this is how we model a moderator. If you want to explain that this is a moderator, you need to draw it like this. So this is again one more modeling convention that you need to use. Mediator is drawn like this. Variable, through this variable, it mediates. This is a mediator. This is also kind of a mediator or an intermediate variable. So this is one full model. So that completes the presentation. So exactly we have completed.